Hi everyone, good evening. Welcome to week 2 of COMP6080. Today we're going to be kind of talking a little bit more about JavaScript, which is super exciting because I guess that's why many of you are doing the course. I think a couple of just simple admin matters. Firstly, I've left a non-email notice because I respect your inbox on the WebCMS3 homepage, which basically just says that there's going to be a Zoom call tomorrow night from 8 to 9. It's basically like a community call, something I'm just trying to do once a month, where anyone can come along and just hang out, basically. There's no real agenda or topic. It's a chance, I think. It's a chance where I get to see a few faces I might not have seen and ask a couple of questions. It's a chance for you to come along and ask questions to other people. To be honest with you, like last time, like 30 people came, which means that you're like, realistically, most people don't really talk that much, but that's okay. I understand some people, like, it's COVID, it's lockdown, some people just like to come along and sit in and absorb the presence because of like other people there and stuff. So yeah, so that'd be great. If you want to come along to that, please just feel free to. It'll certainly be available to everyone. Just follow this Zoom link. In terms of today, what today's lecture is about is it's the second live lecture, and its focus is on the JavaScript ecosystem. So we're going to be talking about the JavaScript ecosystem. All the information's on the homepage. What I will say about the live lectures, so this is a reminder because this was a little bit different from last week. These live lectures, week 2, 3, 4, 5, etc., assume that you have watched the other lectures this week. So for instance, if you're here today live, or you're watching the recording and you haven't, for instance, watched in particular the JavaScript syntax lecture and probably the npm intro lecture and the React.js lecture, then you probably want to pause this and go do that first, because things we talk about in the live lectures on Thursday will presume that you have actually seen these things. So that's just something to keep in mind. So I'm not gonna go through things that are already like well covered in these lectures. You can still watch. It's just you might miss a few things in terms of their relevance. So what we're talking about today is the JavaScript ecosystem. I just want to get my own slides up for this. Give me a second. I kind of forgot that there wasn't a link on WebCMS3. So in terms of the JavaScript ecosystem, the reason this lecture is really important is because 20 years ago, JavaScript was a really simple thing. It was essentially like, hi, you have a language that you can run on a web browser. That's it. A few people have said some stuff in the chat here. It's like, honestly, as long as you've seen this one, you'll be okay. It's just that these two are helpful, but as long as you've seen this one, I think you should be okay. Not using Canva for slides, a travesty. Yeah, I'm not a massive fan of Canva for programming lecture slides. Maybe more general presentations, but this is fine for what we want to do. So yeah, as I said, 20 years ago, JavaScript was really simple. It was like, here's a language that can run in a web browser. That was it. Though these things have certainly developed since then. Now we have JavaScript that has, superset languages. It's got frameworks that are their own languages. We've got another type superset language. We have Node.js, which is a way to actually write JavaScript on the command line. And if you've been to the tutes this week, or if you've seen some of the lectures, there's all these confusing things like, okay, I get JavaScript as a language, but sometimes I can run it as a command line tool, and then other times I can run it in the web browser. And then there's this thing called React, which is kind of JavaScript, but kind of not. And the point of today is to tie all those ideas together and really paint a full structural understanding of the pieces of the puzzle. So first thing, which is to answer these questions I just mentioned, which is like, what is all this stuff? So one of the first things to really understand, and some of you will have a very intimate understanding of this, some of you will have an intuitive understanding that you probably never thought about, but it's really important to think about three big concepts here, right? You have a language definition, you have a compiler or an interpreter, and you have the source code that runs. And if you understand these three things separately, everything gets a little bit easier to get your head around. So a language definition is basically, how would you put it? It's like a rule book. It's quite literally like a dictionary or some kind of thing that says, all right, in this particular programming language, you can have if statements, you can have while statements, you can have else statements. If anyone ever made the shift from, say, C programming to Python, you know that in C you have something like an else if, whereas in Python you have like an elif, ELIF kind of thing. The decision as to what that is based on people who sit down and write the language as like a rule book. Like you could write it as a PDF document, for instance. A compiler and interpreter is something that goes and takes a language definition and actually goes and makes a program that can take source code you write, and turn that into like a meaningful piece of execution based on the rules defined in the language, you know. So someone writing a compiler will say, all right, well, we're going to get in this source code, like the code you write, Python, JavaScript, C, whatever. We're going to take it in as essentially a string of ASCII characters, and we're going to do something with it according to this rule book, which is the people who wrote the language. So, you know, again, for an example, it's like Python is a programming language with a particular standard. And what would you say, like Python 3 or like Python on the command line, which you might have typed before. You know, whenever you write something like Python 3 here, or, you know, you create a file, hi.py, that prints hello. Like, this is source code you're writing here. The Python language is just a set of rules, and when you do Python 3 hi, you're actually running the Python interpreter, compiler, however you want to think about it, on that piece of source code to get an output according to those language rules. So that's really the crux of that there. You've interacted with these things all the time. These are text files, these are programs you run, these are rules. You probably interacted with language definitions the least, because many of you would have never really sat down and really read through, like, you know, the Python handbook in a lot of detail or anything like that, or how the, you know, the fundamental syntax of the language works, but you probably have a sense of it anyway. Okay, so the summary of this is that, as I mentioned before, compilers and interpreters take source code and produce executable programs. The way to interpret the source code into an executable is provided by the language definition. That's pretty much what I said, but that's like the formal understanding of it. So those things should be a little bit clearer. Let's try and understand it, though, in the context of JavaScript, this horrible, you know, web of a mess that's very confusing. And I think, like, to understand JavaScript, again, is super complicated. I will give you some examples of things that are less complicated. You take a language like C. C is a language that has some slight modifications over the years and different versions of GCC, the compiler. A language like C++ is very similar. It has some updates to the language, albeit a little bit more aggressive in the recent years. You have a language like Python, which is essentially Python 2 and Python 3. Two massive interpreters. Python 3 is obviously getting little bumps and boosts all the time, but still fundamentally relatively similar. Like, it's just one kind of thing. Where JavaScript differs is that most of the JavaScript you write is always going to be in some kind of JavaScript file, but we're not interested in the source code here. What we're mainly interested in are the language definitions and the compilers interpreters. So let's start with the language definition, because that one's kind of the easiest, right? There's a certain language you might have heard of ES or Ecmascript, and this is really important because when people actually refer to JavaScript, the syntax that you're interacting with and writing is actually what you'd call Ecmascript. Ecmascript's the actual, like, language itself. Like, I know we call it JavaScript, but it's actually Ecmascript. I don't really have a great detailed answer for you on why it ends up being called JavaScript, but, you know, you go look up the rulebook online, you go look up Ecmascript language, and you'll find, you know, all the stuff relating to it here. Like, what do we have here? Ecmascript's a general purpose programming language, standardized. It's a JavaScript standard to ensure the interoperability of web pages across web browsers, blah, blah, blah. Basically, they're like, it's the language that JavaScript is, right? And there's lots of different versions of it, and you can start to see these here. And the language definition itself, again, this is not a compiler, this is not a program, this is a standard. It's It's a rule book. So Ecmascript is, the first, like when we say JavaScript was released in 1997, what we're saying is the first Ecmascript standard was released in 1997. And it's had some major releases since then. Sometimes we shorten them to be like ES5 or ES6 to refer to specific versions. ES5 and ES6 are two really common ones you'll hear about, and we'll talk about today. So Ecmascript 5 is ES5, Ecmascript 6 is ES6. Sometimes you can refer to them by the year they were released, like Ecmascript 2016, etc. You can read up on it more, though generally speaking, again, most of what we're going to focus on in this course is ES5 and ES6. They're two different versions. You can kind of think of that like Python 2 and Python 3. Same language, just kind of, one's a big step up from the other one. So that's just all a language definition. In terms of the compiler or interpreter that takes this language and turns it into an executable, where things get a bit more complicated is you have to understand a compiler or interpreter is actually kind of two different things. Firstly, there's the Ecmascript Engine. This is the thing that actually parses the text, deals with the if statements, the looping, the variables, like that really fundamental stuff that you picture, right? So, I mean, what do we got down here? Nothing super useful. But I think we have some examples on the next slide about different kinds of Ecmascript engines. These are just language parsers, right? It's really what interprets what you write. A runtime environment, though, is something that's kind of built on top of that, and that's what kind of makes something usable. I mean, you can really imagine some of these things through a whole bunch of analogies. One of the more obvious ones is like if you think about your Ecmascript engine as the actual, car engine and chassis or something, the wheels or whatnot. It's the thing that actually does most of the work and is like the foundation of it, and then you just build things on top of it, right? And like a little fun aviation fact for you all is like, there's a whole bunch of different like jet engines out there in the world, right, on planes, but fundamentally a lot of those jet engines are actually built on the same what they call like core. So a lot of the insides of jet engines are actually the same because they're really hard to get right. They're really hard to like get perfect, invest the time into, and everything like that. So therefore, it's like a worthwhile endeavor to kind of only do it once and do it right. So these Ecmascript engines parse most of the language. The runtime environments are the wrappers around it. Now, what those wrappers are things like Node.js, Google Chrome, Firefox, or more specifically things like WebKit, which is kind of what Chrome's built on. But so when we talk about this thing about, okay, well, if JavaScript can be used on Node.js on the command line and it can be used on the web browser, are they both the same thing? The answer is kind of maybe, because both of those are going to be using the same Ecmascript engine sometimes, the thing that actually parses the JavaScript. But on Node.js, you have things like opening and closing files, for instance, argc and argv. These are all parts of the runtime environment that don't exist on the web browser. And then similarly, on a web browser, you have things like listening to click events, or listening to keyboard events, or accessing the window object, or the URL parameters. These are all parts of the runtime environment built on top of an ES engine for browsers. So how this then looks in practice is you kind of have a system like this, where over on the left-hand side you have all these different Ecmascript engines. You have Ecmascript languages like ES5, which is ES 2009, ES6, which is ES 2015, ES7, I think ES7's 2000. I mean, let's look it up. Let's look Ecmascript 2017. I can't remember which version this is. Or if this is ES6. Maybe I got those the wrong way around. Let's look at the versions. So what do we got? 2015 as ES6, 2017 as... Oh yeah, they stopped using the 6 stuff. I remember now. Sorry. So I'm pretty sure after ES like 6 or 7, they started trying to refer to it as years, because I think it got very confusing for people. I mean, C++ does this with like, C++ 11, 14, 17, 20 and whatnot. So I think they're trying to do the same thing. So even though they say things here like the 8th and 9th edition, I do believe from what I've read, they're trying to just keep it to the years and get a more regular release going. but this was like the big jump. In a lot of programming languages, there's often like a big jump where things like dramatically improve in terms of like what they can actually do. But let's get back to it. What are the Ecmascript engines? Well, there's a couple of big ones. There's like a JS Core or Nitro engine that's a little less popular, but the most popular Ecmascript engine is by far the Google V8 engine. It's a JavaScript engine built by Google. You could Google this as well, ironically. V8 Google, V8 JavaScript engine. Like, what is it's an open source high performance JavaScript engine written in C++. That means that it's essentially a something that crunches the JavaScript very quickly as possible. It's used in both Chrome and Node.js. So it's like, I'm V8, I'm an engine. This is a runtime environment that uses me. This is a Node.js environment that uses me. I implement Ecmascript, the language standard. WebAssembly is a separate thing that it does too. Nothing we're talking about at the moment. And it runs on Windows 7 and all these kinds of different things, right? A few comments in the chat. This diagram's relatively oversimplified. There's going to be some details missing here. If there's a couple of factually wrong things, please just like email me after and I'll tidy it up. But the main point of this page is not for you to go, oh, I know that Google Chrome's built with the V8 Ecmascript engine, because like, okay, that's like a random fact that I guess is interesting to know. It's more that we're trying to convey that, different runtime environments are built on different engines and implement different standards, or like there's a various web of things here, and kind of understanding the intricacies between these things is kind of important. So where this leaves us then is talking about some more specifics around the engines and runtime environments. So the language is the language. Like, we could spend some more time talking about the Ecmascript language, but it's just going to be hard if you haven't spent much time doing JavaScript, because I'll be like, here's all the random features it can do, and you'll be like, cool, I don't know what any of that means. In terms of runtime engines, just checking Google V8 engine as like an example, because we could look at other ones, but let's keep this one simple. It is the compiler. You can see if you look at kind of the schematic diagram of it, that it shows things like, okay, it has a parser and an abstract syntax tree. Oh, I forget what AST stands for. And, bytecode generator. Well, all this really means is that it's what actually takes your language and breaks it up into a syntax tree and then converts those to particular pieces of bytecode. That's the kind of case you see with other languages, I think, like Java as well. Because the point is that, if you have a language like JavaScript, even though it's like a scripting language, all of those operations still need to be broken down into more basic things. So when you have a JavaScript program that says, const A equals B plus C, that still in the end has to come down to some kind of processor level operation or some abstraction of it. And that's what the V8 engine's designed to do. Because a CPU on your computer doesn't just read JavaScript syntax, right? And this is true for any programming language. And this is what actually does those really boring nuts and bolts pieces. You'd probably see a bit of Curtis in the chat as well in relation to some of this stuff. Curtis has quite a bank of experience on some of this stuff. So generally speaking, if he's saying stuff, it's probably true. He's also pointed out that there's a course 3161, which is probably worth mentioning. There's a few of these courses we have at uni. This one is Concepts of Programming Languages. I haven't had a great... Oh, it's sad that it's hidden. But, I mean, the summary of this off the top of my head... Okay. Perfect. Programming paradigms. I mean, this is all about... one of my close friends has done a lot of this stuff. This is all like really thinking about like what a programming language is specifically. So when we pulled up those kind of diagrams before, it's like, this is like thinking about programming languages conceptually. Forget even compiling it. Let's just like think about like what is the conceptual differences between object-oriented and imperative programming and functional programming. There's another course at UNSW called Programming Languages and Compilers, which I don't remember the course code for. I assume it's still running. I don't know. Someone will probably tell me before unless they canned it. Everything changes around here so quickly. Yeah, so 3131, COMP6131. I don't know if this is still running. I guess so. Term 1, yeah, great. I think this is it, 3131. This is a great course if you want to learn more about the kind of interaction between programming languages and compilers. So 3161, from what I understand, is more focused on programming languages and getting very deep in that area. 3131 digs a bit more into how do you write a compiler for a given language, which is actually probably most relevant for like this kind of V8 stuff we're talking about here. Sorry, I jumped ahead a slide. So this is what parses the language, right? Really simple. That is the Ecmascript engines. When we start looking at runtime environments, I mentioned the two main runtime environments that we're interested in are Node.js and web browsers, in particular web browsers, but Node.js is also somewhat interesting. I feel like I made a mistake with that diagram there. That's okay. Forget that diagram for a second. But what Node.js is, and you probably heard a lot about this Node.js came about, I think, in like around 2010 or something. And it was the kind of brainchild of someone who said, you know what? JavaScript's an interesting language. We already have an engine that can interpret it. Why don't I just write a command line interface so that we can interact with it just like we do with Python or something, Like, there's no reason that JavaScript has to run in a web browser. It's just a language. So Node.js was written to give like a command line interface to wrap a V8, the V8 JavaScript engine, right? So things like the event queue, if you go and watch Anna's lecture in week 3, which we haven't come up to yet, things like file input and output, things like, again, processes and sys argv and stuff, all of these things are built into Node.js. And it just uses V8 as the actual core parsing and compiler. So it's a layer on top of it. Jin says in the chat, could we say Node.js is a kind of engine? It's a runtime environment that allows you to interact with it that uses an engine underneath. Like, you kind of have to think about, again, like I gave the example about the car. If someone just gave you a car engine that actually, pistons and everything and turns a shaft, and they said, here you go, here's your car, come drive to Newcastle or something, you could not drive that. It's what powers the car. It's what does the hardest parts of it, but it's not a car per se. You have to build something around it to make it actually usable. And different people might take the same engine and build different cars, for different purposes. But that's like the engine's kind of the core part there. So that's what Node.js is. It's really what gives you that interface and interaction and that environment to actually do work in. So maybe not Wilhelm says, so Node.js is just a browser without a window. Look, I mean, I'm sympathetic to that description of it, because if you understand it like that, then I think that makes sense, right? Like, Node.js is a browser without a window, and a browser is Node.js without a command line and file system and stuff. Sometimes they both implement the same thing. So if we actually look at a web browser, such as Google Chrome, you can look at the architecture of it over here, and I understand, because I'm bandwidth limited here, I think, I'm not sure how well this image has compressed on the internet, but it'll look fine in the recording at least, or you can just look up the lecture slides. But a web browser is this big complex thing, where, as we've kind of seen last week, a web browser loads an HTML page and then it does a whole bunch of stuff. And again, if you've seen Anna's lecture, what the browser implements, the actual runtime environment that is a web browser, it does things like the DOM, the document object model. It manages the DOM. It actually builds that, manages that model. It has its own event queue to deal with like events like clicks and other asynchronous events. It deals with all of the networking elements, like, the actual network requests that are made. It parses CSS. It figures out how to draw things. Like, all of this is built by the browser, essentially. But the actual processing of the JavaScript happens inside the V8 engine. So you can actually kind of see here as a summary that's V8 on the left. So V8's on the left or bottom left. The runtime environment's the web browser that wraps around it and provides more detail, and that's actually what a web browser is. So, I've got on the left here, the JavaScript V8 engine is a small but critical part of a web browser that allows for the execution of JavaScript. So, web browsers do things like mutating the DOM and other examples I've just given here. NCSS, which is like a whole other separate thing, right? Like parsing CSS and painting is just kind of separate to JavaScript, and a browser's job is to glue all of these things together. Sorry. So that's kind of the difference. So Node.js command line tool, same kind of thing as a browser. I don't have a diagram for some of the detail here, but it would have all of those things. They're not always mutually exclusive too, right? Like a web browser has something like the window object and a sense of URLs and stuff. And Node.js, again, I mentioned the examples as like, it has like a dealing with file systems, input, outputs, and a few other things. But sometimes they both do the same thing. Like they both implement their own kind of event loops, because they both have asynchronous capabilities. So even though in Node.js and in a web browser, you can do asynchronous things and you can do promises and callbacks, which we'll learn about later, just because it's in both, that doesn't mean it's like in the V8 engine. The V8 engine is a very like focused, specific thing. It just happens that the event loop and queuing is actually built in both of those runtime environments for different purposes and different reasons. Are there any questions at this point? I'll just take a pseudo pause and just see if people have any questions about the language, the V8 engine, how these things interact, Node.js. Give you like 20, 30 seconds. Cool. Okay. Super engaged. That's good. Or everything's just super clear. Maybe not. Wilhelm says, is Beautiful Soap a DOM? I have no idea what Beautiful Soap is. Beautiful Soap. I guess. Looks like it could be part of one. I'm not sure what the distinction is between being part of one and being is one is. It's a Python package for parsing an HTML document and creating a tree. Yeah, I mean, a DOM fundamentally is just a structure, a dynamic structure for representing a web page. Like when you look at a web page, it kind of looks flat to you, right? But it's this big layered effect that is coming from a tree of objects built in HTML, and each of those objects in the tree have properties. And you're essentially looking at the DOM anytime you click on a page and you inspect it, right? Like you're looking at the DOM here. It's just this giant tree. And all of these things have properties. Like this is a DOM inspector, essentially. Musa says, is Node.js like an environment that has all the libraries to run JavaScript? Yeah, I mean, so when you're using Node.js and you import a library, the act of that importing is a Node.js runtime environment thing. So if you're in, like, you look at like a Node.js library like file system or paths or, networks or web servers, these are all like importing is a Node.js thing. It's not part of the V8 engine. I mean, just quite literally speaking, most of the time when you're doing stuff with a Node.js script, you are interacting with something that is built on Node.js. The point is that when you get to a low enough level, that starts to be actually run by the V8 engine. Because, there's just some fundamentals about how JavaScript goes through loops and how it'll store data. Like, the question around, you hear people say things like, oh, did you know JavaScript stores all of its numbers as strings or blah, blah. Like, these are all really low-level stuff that is kind of what the V8 engine's concerned with. Muster asked another great question, which is it like pip in Python virtual environment? So I think this might be covered in the NPM intro lecture, so I won't go into it too much depth, but NPM is the equivalent of pip. So like the comparison we give students is that Python 3 is like Node, it's a command line interpreter runtime environment. And then you have pip, which is a package manager, and you have npm and a few other package managers, which are package managers. Like they're quite the same thing. Yeah, and then Diarmuid says, are we going to look deeper into the DOM later in the course? I don't know if I'd say we're going to look into the DOM later. Like we've kind of learned what the DOM is. We're going to use it a lot. We're going to interact with it a lot and get more comfortable with it for sure. Okay, so now that we've had a look at Google Chrome, let's, funnily enough, go into Musa's question about managing packages. So Node.js is a command line interpreter, but it itself does not, out of the box, manage packages. And what do we mean by manage packages? Well, we mean be able to install libraries from the internet that can do stuff. So, for instance, there is a Node.js library for a web server that we are going to talk about later in the course. It's called Express Server for Node.js, and the thing about this Express server is, I was hoping I could get it without typing in npm, but I guess we're just going to have to do that. This Express server is an actual thing that you can like download and import like a pip install and use as part of your projects, but it's not on your computer when you install like Node.js. Because installing Node.js it's just like installing Python. You're just installing an interpreter to your system. So npm is a tool we use to actually manage these packages. It's how we manage packages in a particular project. There's a few different package managers like yarn and pnpm as well, but these are what manages packages and they're the same as pip. There is an npm intro lecture, which again I said that we assume that you watch it, but I know a few people haven't watched it at this point, so that's totally okay. Go and check that out to learn more about that, and we'll continue to talk about that throughout the course because it comes up in lots of tutes and lectures as well. This is also from the npm intro. It's just kind of important for the next little things we're working through. npx is a command line tool that runs a particular npm library in an executable mode. You've probably seen that already if you had a look at, again, the npm intro or the Create React App lecture. Because sometimes you can actually install an entire module, but you want to install it not to import it, but to actually run it as an executable. So if you use npx on a particular module, that'll work for you. Now, yeah, it's like pipx. Now, most of this is just like, most of those two things are pretext to us kind of now segueing into React.js, because kind of until this point, it's like, okay, well, I get Node.js here, and I get that you can open up a terminal, like here's an Ubuntu terminal, and I get that you can open a file called hi.js, and in that you can say console log, hello 1+2, and all of this will be like parsed and outputted, and if I run node hi, it does the thing. Okay, there's my runtime interpreter there for Node.js, and I can write the same thing in the browser just like we've done in the week 2 tutorials, right? There's 2 different ways of doing things, and some things won't work in both. Great. But then what in the world is React.js? Is this another language? Is this JavaScript? What is it? So React.js itself, and this is very similar for other kinds of popular libraries out there you'll see, such as AngularJS or Vue.js. React.js is kind of like its own pseudo language that's loosely related to JavaScript, or as a superset of JavaScript essentially. And what it does is it builds or transpiles into standard JavaScript compliant code. So essentially it's a language that when you build it, when you compile it, it turns itself into boring old JavaScript. So the JavaScript that you've written or are writing for assignment 1, or the JavaScript that you've seen in tute 2, or some of the exercises in week 2, that's what I'm just going to refer to as boring old JavaScript, or what we sometimes refer to as vanilla JavaScript. It's really, really simple. React.js is a more complicated language that essentially compiles into normal boring JavaScript or vanilla JavaScript. This leads us to an important distinction here. This word transpiling, you might have never heard of it, you might have heard of it and know what it is, you might have heard of it and have no idea what it is. Compiling is a broad term we use to describe when you take source code written in one language and produce an output file typically written in some low-level language. So, when you have something like, say, you have some C, C++, and you compile it, you end up, I don't know specifically what it outputs. I'm not sure if it's just straight x86 commands, but it's basically like assembly, right? It's like assembly-abled. This is not my expertise area. It's something that can kind of be interpreted by a processor directly, So it's like a lower level, below like an actual English-based language. Same kind of thing, like you can have programs out there that might convert something like Java into something like C-like or straight down to some kind of assembly again. Transpiling is the broad term we use to describe taking source code written in a language and converting it to another source code, typically in a different version of the same language. So it's essentially something that, say, can convert, take a Python 3 source code and convert it to like Python 2 source code. Or in these cases, it can take newer versions of JavaScript or JavaScript-like languages and convert them to boring old JavaScript. So transpiling still has the same mechanics of compiling, in the sense that you're taking in a file as like kind of ASCII plain text. You are interpreting it, breaking it up often into some kind of abstract syntax tree. It's just when you output it, it happens to be a very similar language to what you put in, or at least, again, a subset of that language or an older version of that language. And this is what's happening all the time when it comes to what we do with React.js. Because you got to think about React.js as like a form of JavaScript with bonus features on steroids that a web browser can't understand. It's not something that can be run. You can't just run something like React.js or Vue.js or these other fancy libraries straight in a web browser. You need to convert them to boring old JavaScript, because all your web browser knows how to work with is boring old JavaScript. That's a bit of an understatement, but an overstatement, but that's okay. And I've got a few other curious beans here. I mean, one of the challenges with this course is that people have a wide array of background knowledge, but yeah, so most things like TypeScript, React.js, again, Vue.js, all of these things are supersets that are kind of, for lack of a better word, they're like languages that were never designed to run in the web browser. They were never designed to actually be runnable directly. They were designed to be languages that were defined, easier to use, and then there were compilers written for them, which convert them to simpler versions of JavaScript to be run in the browser. So where this kind of leads us is that one thing that we kind of assume in the web industry is that we nearly assume these days that all, and this is very web browser specific, right? We assume that all web browsers are essentially ES5 compliant. So ES5 is JavaScript 2009, I think. Ecmascript 2009. Because of that, what we do is that if we're writing code for web browsers, we will try and write code and make sure it's transpiled to that standard. Because if it works, if we can make it work for an ES5 language, then it's probably going to work in the vast majority of web browsers, right? It's not going to work in like some of it won't work in some of the older browsers if you have some of the newer versions of stuff. Now, we've mentioned before that React.js is a very special tool that we use to that we can transpile into ES5 compliant JavaScript. You can also just convert normal Ecmascript 6 stuff, new versions of JavaScript, to the old one as well, if you want to. So like if you were, say, for instance, building a website with not React.js or these other things, you were just writing it in exciting old JavaScript, right? Like just vanilla JavaScript with newer versions, you could still transpile that down to earlier versions. So transpiling, there's not like the transpiler. There's a whole range of them. There's a whole range of different things. But the point is that there's all a process out there where there's this like sprawl of different languages, capabilities, frameworks, but a general trend is to still try and transpile them back to something simpler that is super common and easy for browsers to support. Now, a natural question is that when you, like, people kind of ask all the time, so do we transpile for Node.js, right? So if you kind of have like what would you say, like a Node.js script that's written in like a new version of Ecmascript or something, should you, for instance, have to transpile that down to an earlier version. Generally speaking, the transpilation is only really a big deal when it comes to web browsers, and the reason for that is because if you're working with a Node.js script, you're tending to work with that on your local machine or on a series of servers you control, where you can actually control the versioning that you're dealing with, right? So it's kind of like, you think about like Node.js stuff, it tends to run on your computer or computers you control. It's not really something that, like, if you distribute it out to someone, you're going to get a million people running a Node.js script, because it's a command line interpreter. Web browsers are very different, because if you build a website that you want accessible by, like, how would you put it? Like, accessible by millions of people, for instance, they're all going to have different web browsers on the phone, on tablets, on different versions of different operating systems of different whatever, which are all going to have subtle differences. So it's really important to find that lowest common denominator, particularly with like web browsers. So this transpilation topic is quite specific to web browsers. Maybe not Wilhelm. So I'll just make a comment really quickly about the video quality stuff. So you mentioned about, like, I think you're kind of implying, like, so we're streaming at 60 frames a second as opposed to 30. I did some very extensive tests with this before the term started and found that there was no improvement in quality on 30 FPS. I think it's the way the bitrate compressions work. I think even though it's 60 FPS, like the stream that I tried 30 and it didn't get any better. So I'm sorry, it's a limitation of the internet and the availability where I'm located, and it's kind of just out of my control, sadly. So yeah, I can change the quality to something slightly lower, though. This is basically streaming at the maximum bit rate that's available to stream steadily, which is about 2 megabits a second. 2 megabits a second, sorry. So I tried other things as well. Yeah, I mean, it's fine for recordings. Like, that's the main thing. It's fine for recordings. From what I can tell, yeah, I'm not 100% sure. Like, I've tried this out myself a bunch of times. We can keep digging into it too. Though it's hard to say. What all I found is that I'm streaming at about 2 megabits a second at 1080p 60 FPS with the bitrate compression. It's pretty okay if the internet's stable. It's just you wouldn't want to see anything in motion. I think a lot of the bitrate compression makes things go pretty bad. But I'll keep playing around with it. It's fine. Cool. So what we're going to do is we're going to start playing around with Babel or Babel. I've still never figured out how to actually pronounce this one. It's a transpilation tool, and I just want to kind of get your head around transpilation, and we'll talk about this a little bit before the break, and then we'll get dug into React.js. So I'm just going to call it Babel, even though I don't know how to pronounce it. Essentially, this is a transpiler for JavaScript. In particular, I don't know if this works natively with React, per se, but what it does do is it helps you take a later version of Ecmascript and convert it into an earlier version of Ecmascript. And this is what a lot of like modern tool chains use to make sure that you can write modern code that get converted back. They've changed their site since I've last looked at it a little bit, so I might be out of my depth here, much to my surprise, which isn't great. But essentially, there's a lot of new language features with JavaScript. So like, if we go back to our Ecmascript Wikipedia page, you kind of see in all these things, they say, Ecmascript 2000 and the 5th edition, which was 2009, right? This had a lot of basic features, which I wouldn't even call features anymore, and I don't think many people would call features. When you start to get to Ecmascript 6, and this is probably standard now, by the way, like across pretty much everywhere, there's new syntax including class declarations, there's different ways you can import. So there's a new way to import, because in like previous versions of Ecmascript, for instance, if you wanted to say like import path from path, so this is import from the path library as the path variable, you would kind of have to write something. Well, I mean, I wouldn't normally write that whole thing. Normally, like the old way to do this in Node.js was to write const path equals require path, right? So this is kind of like the older, I shouldn't call it the same thing. This is kind of like the older style way of importing with Node.js, right? And you can see that because how that one was transpiled here on the right hand side is it's taken quite literally. So I think this is ES5 compliant, I think. So you can see here, like, because it came in at ES6 was the new one. So what they did in ES6 was they kind of said, oh wow, this is super ugly. This is like really a weird way to import. Why don't we do, you know, something, say, closer to Python? Something a little more friendly, because you can see the top one here just kind of follows a more similar pattern to what you might be used to in other languages. But even though we import it like that, if we want an ES5 compliant interpreter to understand it, we will have to transpile it to something like this. And you can actually see here, it's kind of the same as what we've written. It's like variable path equals require this. Now, I have no idea what this interop require default is. This is definitely some real fancy boilerplate that has some meaning that I don't understand. But the main point you can see here is it's converting it to an older style because this particular language feature is not implemented in an ES6 Node.js interpreter. And you can see this for a whole bunch of things, like, I'm not, like, what other things did they implement? Classes, I don't know what classes look like, class foo, if that'll come up as something different. So that was clearly part of it. Like, I don't keep all these versionings off on the top of my head, and we're probably not even converting to, I can't actually tell from this tool. I don't really use this tool much. I was kind of just going to talk about it lightly. Not 100% sure how to change what we're running here. Oh, it's like trying to run React. I don't know. Interesting. That's okay. So, examples of other earlier things that, like, things that were added to the language in like more recent versions was like the spread operator. So the spread operator was never historically a big part of JavaScript. So if you, say, for instance, had a list of items like this, 1, 2, 3, 4, 5, and you wanted to create a copy of that list and add a fifth element, you could use the spread operator, new items equals the previous items with the number 5, right? So again, the particular transpilation that's happening here, the versioning here is both the same. But newer and newer features, for instance, they have to be transpiled. As we'll learn in week 4, there's a whole topic around asynchronous commands that we'll see, and a lot of those are still transpiled. So I don't remember when it came out. I remember being a kid and hearing about it, but essentially JavaScript many years ago introduced promises, which is going to be a massive topic for you in your second assignment. And then they realized that promises were really ugly, so they introduced some nicer syntax to interact with it. But with that nicer syntax, again, it wasn't supported by all browsers. So they still transpile that in many cases. One comment about browser compatibility that's very relevant here is that the kind of picture to paint that would be wrong is this idea that, like, these new versions of Ecmascript, like 7th, 8th, 9th, 10th edition, that browsers can't deal with these. Most browsers can't deal with these. It's super new technology, so we have to transpile it so that all the browsers out there can deal with all this, like, fancy new stuff. The reality is, if you're a desktop, laptop, mobile user using like Google Chrome or a major browser like Google Chrome, there's a good chance that most of JavaScript's new features work natively in the browser, because these big companies love to just, you know, keep these things advanced and up to date and modern. So most of the transpilation ends up happening for a small number of people. You know, like this kind of transpilation you'd see, well, importing doesn't really happen in the browser as much, but the point is that it's the other way around. So it's like, if you just wrote a newer version of JavaScript and tried to run it in a web browser, it would most of the time just work fine. However, sometimes in a small number of cases it doesn't work fine, and a big part obviously of web development generally is making sure that your stuff works ideally everywhere. Okay, so after the break we're going to come back and we're going to maybe chat. We're going to run through an example of just a React app, just making, like, getting one up, looking at the transpilation, looking at a Node.js kind of script running alongside it, and that'll be kind of the end of it. So we won't run till 8 naturally. But what I'm going to do just before the break just before the break is that I'm going to get my example building React app going because it takes a little while. So if you've seen the React intro lecture, which you should have watched before this, I'm going to create let's just call it week 2, this random week 2 folder on my computer. We said before that npm is how you create a package managed environment. So if I was to say npm init here, and I'm going to get asked a bunch of questions, which I can just click answer to get the default answers. And I say, yes, that's okay. What's happened now is inside this folder, I've got my own little virtual environment if you want to use Python language. So I've got my own little virtual environment here. What I can also do, yeah, I do have the backend front end mixed up. Thank you. What I can also do here is I can actually go and start installing create React app, a React app, right? So there is a particular npm library called create React app, but this isn't a library like you're downloading a JSON library or anything like that. This is a library that was designed to be executed. So this library, create React app, which is downloaded 137,000 times a week, this is a tool that helps you actually get set up to build your first React app, which is something that we're going to do much later in the course, but we like to just chat about a little bit early on in the course so that you can kind of get your head around it. To start installing that, I can use the npx command, which is like an npm install. It's like I want to install this module, but instead of installing it as a library item, I want to download it and I want to execute it like it's an executable. So if I do this, it will do, this takes I don't know, 4 to 5 minutes, so I don't know how long it'll take, but we'll do the break over it so you're not sitting here awkwardly. Oh, it wants me to, sure, okay. I'll just call this front end, whatever, doesn't matter. Read the instructions, everyone. So last kinds of questions, Jin says, do we consider Node.js as the back end, Express as the back end, and React.js as the front end? Yeah, so I'll try and touch on this more after the break, because this stuff can get really confusing really quick about what in the hell is Node.js versus React.js versus all this kind of stuff. So we'll talk about that more after the break. And I'll reiterate now just before the break, and I'll reiterate at the end. The point of this lecture is not to scare you with all these things, because most of what we're talking about today doesn't have any massive impact on you practically. React's later in the course. It's weeks away. It's 5 weeks away. You don't write much Node.js at all in this course. The reason we're talking about it is because we kind of feel that if we don't tie all these concepts together, then you're just going to kind of be learning these little things and not know how all the pieces fit together, which is really important as far as we're concerned theoretically. So let's let that install. Let's take a break. I'll turn the bit rate down a little bit. Try that out after the break. But yeah, cool. All right. See everyone in 5-8 minutes. We'll start up at 7:07 or something like that. Cool. The break. Where we left off just before the break was we were talking about React. We're talking about React as a basic idea and what in the world it is and everything else. Where we're going to dig into now is just have a little bit of a look at how React transpiles things. So I've just created a React app. This is demonstrated in a lecture previously, but it's already here as well. And I can go into that folder that I've created. I can go into front end, and then here is my React project. This is its own little npm project. You can have an npm project within an npm project. Let me just make this a little bigger for you all. One sec. Sure. What we have here, right, is we've got our own little npm project that is for the React app, and we can actually go and explore those files together if we'd like to in our editor. So what I'm going to do is I'm going to just open this particular folder on my computer so we can have a look at it. Hayden, what do we call it? Week 2. Perfect. Okay, so here we have all of our kind of possible files here, right? Inside, I know you can't see the sidebar here, but it's inside a particular folder, and again, you'll see this if you see the React lecture. Inside of source, there is a file called app.js, and app.js is kind of like the template stub file for a React app. Now, You've seen this in other lectures, but we'll just kind of do it again quickly. Here's my app.js. This is the whole file. My syntax highlighter is not being kind to it. Let me just fix that up. Yep. So this is the whole React file. Now we're going to again talk about React later in the course, but again, the kind of question that comes up is like, okay, well, is this like, is React.js npm? Is it Node? Is it JavaScript? Oh, like, what is it? Well, let's just kind of, I already changed the stream quality back, by the way. So let's just actually run the React app to start. So when you're running a React app, you can easily run it just by typing in yarn start in the actual project. And what that'll do is that'll bring up the particular, that'll bring up the particular runtime environment for the React app, which you can pretty much view by going to the page that it opens for you, right? So the whole point of React is it's this like super language. Think of it like it's like JavaScript, but with more stuff in it. And that's why it kind of looks weird. And again, this comes up later. Like, it kind of looks like JavaScript. It kind of looks like HTML. There's a bit of subtlety here that you can dig into more. But one of the cooler things about React is that it's a much friendlier development environment than what you might be used to and what you're probably going to be working with in the coming weeks. You'll notice things with React, like, for instance, if you edit particular words in your file, like I can add hi Curtis right here. And if I save that, it will just update it for me, and it's a very dynamic way to work on a website. Now, this is the same as other kinds of modern frameworks, of course, but it's definitely a huge step up from just boring old vanilla JavaScript. Here's the problem, though. When, like, a web browser does not interpret React.js, like a web browser does not have a React runtime environment. There is no like massive React runtime environment that web browsers can run on. So we have this problem here where we have, okay, I want this to run on the browser. So how is this happening, right? And the answer is transpilation. It's being transpiled constantly in the dev environment, like without you even realizing this is constantly being transpiled. But to kind of maybe dig into the weeds a little bit more, let's actually do a manual transpilation with React. So I don't know why it made my terminal all small. It's because it's an opinionated little bugger. But in my kind of React.js file here, if I want to transpile or compile my code to something runnable, if I want to go from this React.js crazy language to like boring old JavaScript, I can use one of my command line tools, yarn build. Now, I've had a question already, which was like, npm versus yarn. Which one, are they the same thing? Whatever. They are roughly the same thing. You can mostly use them interchangeably. For the purposes of this course, we're going to use them interchangeably. There's some subtleties to that. React projects like using yarn instead of npm, but they both do the same thing. You can, it's quite a moot distinction. Couple of subtle things you can Google. So what I did here was I did yarn build, which is like npm build. It's saying I would like to build my project. I would like to compile it or something like that. Because we're using React, which is this kind of like pre-ready library to use, it actually built some stuff for us and it put it all inside of a folder in this directory called build. Now, if I go inside that build folder, I actually see a bunch of files here. And if I open up my file system, and I'm just going to it now, and I go to my week 2 folder, and I go to build here, like this, I can actually see all of these files that are here. And I can actually drag this index.html into my browser, and it should run. It's not. What's wrong with it? Do I need to run it in a... Oh, I see what it's trying to do. So let me just tidy this up. If I go to this build folder and I start a little web server, which if you're not... Oh, what is it? http.server. There's a thing you can do with Python where if you run this command, if you have Python installed and you run this command in a folder, Python will start up a web server, and all that web server does is serve static files. There's some long-winded reasons why that didn't work for me normally, but you can see that Python actually started a server for me on this URL. So what happens is if I go to this URL, Python will just randomly start serving files for me, and I actually get my web page. And you can see what it's actually doing here is it's actually serving those files. It's actually giving those files. But let's have a look at this page, because it's not going to look the same as what we saw over here with app.js. If I open the source code, you'll actually see that, I don't know how to word wrap in Edge. I mean, let me copy this into editor. You can actually see this is what the web page is. Look, it's the rainbow. It's a whole bunch of stuff. In fact, it's all like, this is all boring old JavaScript. It's not only boring old JavaScript, it has been, was there a liner? Oh, there's a giant box up the top. Thank you. I was looking in the context menu. There's a whole bunch of JavaScript. It has been compressed in terms of size. They've reduced all variables down to single letters. Anything that isn't a single letter is basically a function name or a reserved word, or a reserved function more specifically. And they've got these other files here, like some CSS files, which have been compressed, and they've got some other files here, like I think there's some JavaScript at the bottom, like a couple of these, which even more. Look at all this JavaScript, right? This is all boring old JavaScript that has been compressed. So what's important to understand then is that oh, the stream just slowed down. Sorry in advance if this is getting choppy. This time of night is just the worst. Gets a bit slow. Seems okay now. So basically what you've seen here is this page, this single page we wanted to make. All of this stuff got totally packaged up into like this boring old stuff. So this is kind of the process of transpilation, because all of this got turned into this and is like totally like just random unreadable stuff, and that's like totally fine, 100% fine. Does this need to be minified? Does this need to be compressed? No, you might as well, because no one's going to read it anyway. But the point of this is not that it's readable. So this is an example of transpilation, and what you're doing in the next few weeks of the course, when you do, we're going to talk about assignment 2 in week 3. We're going to talk we're going to do some more DOM examples next week. We're going to be working with vanilla, boring old JavaScript for many weeks until week 7. All of that stuff is like what browsers can understand inherently, mostly. Then what we learn in the last part of the course with React is like, all right, now we're going to use this other language like React that will basically transpile into this boring stuff that you've been working with for a while, and browsers will run it like normal. So it's just another layer of abstraction. That's all we're really interacting with here, is just one more layer of abstraction. Now, kind of another question someone talks about is, what was the question before the break? It was something about React.js, and is React.js, like, what's the difference between React.js and Node.js? So here is like what I would say to you. Anytime that you have code that is being managed by NPM in some way, or Yarn, or these package managers, it is Node.js. It is being used by Node.js, because it's really easy to look at this and kind of say, well, it's going to run in a web browser. So it's kind of web browser code. It doesn't really use the Node.js interpreter per se. It just kind of runs in a web browser. We just need to transpile it first. But more specifically, what's actually happening here is that when you are using things like imports here and these file system commands, React.js is actually written on top of or using the Node.js runtime environment. So React.js is a language that has a kind of transpiler that's written, I don't know what it's written in, but Node.js is what's responsible for transpiling and packaging it out. So in a way, you're actually kind of, while you're working on this and while you're deving and building, you're using the Node.js runtime environment to do all of your work. And then that's just getting packaged into a whole bunch of static files for the web browser to be run on the web browser. So there's a lot of intricate kind of relationships between how all of these things work. Generally speaking, you can tell that this requires Node.js because it has a whole bunch of imports and stuff in it. And generally, unless your code can literally be dragged and run in the web browser, like, I mean, if I go back to my source folder here and I try and load app.js here, like, this is not going to run. The browser would just be like, what in the world have you given me? This doesn't make any sense to me, because it's just not a language that the browser understands. Okay, where that leaves us is kind of back where we left off here, which is like sorry that the front end and the back end are reversed. We talked about that before the break. So what you end up doing then is you might have a simple modern development environment. Probably one of the most popular forms of software stacks you can build right now would be a NPM managed project where you have a React.js front end and a Express server backend. Express is a particular module that runs on the backend. If you want to think of it more tangibly for the undergrads doing the course, it's kind of like Flask. It's like Node.js is the interpreter, Flask is the library that runs a web server. Similarly, Node.js is the interpreter, and Express is the web server that runs on that interpreter. So, you know, you'll often have a Express backend running a web server, and then you'll have a React.js front end that will actually, you know, be provided to a web page to work with. So, I mean, we've got a bunch of time left. This is really meant to be a bit of an exploratory lecture. So, I mean, what would people like to delve more into for maybe the last 10 or 15 minutes? Because we can do a little demo of Express and talk about an example web server if you want. Like, get a better sense of like what a full stack project would look like. Yeah, they are reversed. I'll fix them up right now because it's clearly a stressor for some. Just to be clear again, the point of these live lectures was to actually do a bit more demoing and exploring, and then focus on the core content for the pre-records. Like if it's very prescriptive content, it might as well be pre-recorded, was the attitude that was taken. Okay. So just to really paint a picture of this full stack environment, let's say then for a second that I have, this is my project, this week 2 project. This is our full stack setup. We want to have a web server, we want to have a front end. So the one thing that's a little bit confusing here is that what we've actually got in this particular setup here is we've kind of created our React.js folder inside of another npm folder. So essentially what that means is that what we've managed so far is we've said, all right, well, we're going to go and create like a little npm project, right? Like this. Maybe that font's a little bit small. We're going to go and create an npm project like this, except what we're doing now inside of that is we're creating a React.js project as like a subset of that. Now, this can be a bit weird. You don't have to set it up like this. You could set it up in 2 separate folders. It really doesn't matter too much, but that's kind of what we've done so far. I just don't want to get lost on fixing that up because it's not going to have an impact for something. But what we might do now is let's actually install a little web server. Let's actually try and run a little web server and interact with npm a bit. You'll start to get a sense of, you know, the Node.js interpreter and the npm library. So I'm just going to Google Express npm. This will pull up the Express library here for me, and you can see Express, very popular, 18 million downloads a week, which is God knows how many a year, quite a lot. Is that 100 million, billion downloads a year? Yeah. Really? Wow. That's terrifying, unless I screwed that up. And you can see here that they've actually got a really, really simple application that they're just giving to us to kind of copy. So I'm going to copy that. I'm going to paste it inside of a file here. So I'm going to make a new file. I'll call it something random like server.js. So I've got my server.js file here, and you can see a few things. You can see that they're using the old style of importing, which we don't have to use. We could use a different style. And the approach here is pretty straightforward. It's like, I'm going to import a library, the Express library. I'm going to create a new web server. I'm going to attach a particular HTTP route to that web server. And what that route is going to do is send a piece of string upon it being called. and then I'm going to listen for incoming requests on port 3000 to run that server, essentially. So it's like set up the routes, run the server. Pretty straightforward stuff. What you're seeing here, maybe just to really pull this out and make it a little bit more explicit, is that this function here, which we might call, like, say, hello route, is actually being passed in as an argument here. So this gets into like the first class functions territory, where it's like this function takes in a request and a response, and it simply calls the send method on a response object to print out hello world. And then what we're saying here is on the app, when someone accesses our URL with a damn it. Sorry. Stream dropped to 0. One sec. Okay. That was a brief moment. Sorry about that. When someone accesses that base URL here, what we're going to end up doing is we're basically just going to call that function and serve that page. So you can see that if I want to run this, I can actually on my terminal simply run node server.js like I'm running a Python interpreter, and it complains immediately that it's like, you just told me to import Express, but I have no idea what that is. Zero idea, sorry. So we actually need to install that. So I can npm install Express. npm install Express will go to like a centralized open source repository, and it will download the Express library and install it on my machine. I think we've talked about this before. You can actually see where that was installed inside of the node modules folder. There's a little Express folder you'll see here. And when I type ls, you can see now that we have a few things in this folder, like our server.js. We have our front-end folder, which has our React app, and we also have our package.json, which is like our configuration for our project. And then because we started installing some modules, we have a node modules folder, which is where all the libraries are installed. That's like the equivalent of the packages folder for Python. So now when I run node server, it will actually run. It says, well, actually it's not going to print anything for me, but it's running. We could add something here to print. But if I go and access localhost 3000, the server's running. So we've actually made a web server now with Node.js and a library. Really, really easy stuff to get off the ground. We could make another function, which we could call, goodbye route. And that one could be, another route that's like /by. And when someone accesses /by, we could just call goodbye route. I will have to restart my node server because it's new source code, right? It's already interpreted it. It's just running. And then if I access /by now, I get the same text because I didn't change the text. It will say goodbye world, and then we get this, and then we get different text, right? So it's a really, really simple server. And remember that you can use more modern JavaScript function syntax if you want to clean up how these functions look and make them more consistent with like how modern function syntax is. And again, what we saw before syntactically was that you can actually take your whole function and just inject it straight into here, and you can similarly again take your whole function and just anonymize it and put it right in here. That might make your code a little bit cleaner. Wilhelm says it doesn't need semicolons, just noticed. Yeah, so I mean, this is like a lot of language. A lot of languages, like the semicolons are helpful, but like JavaScript's pretty good at figuring things out anyway. Like it'll figure it out for you, just like HTML figures out if you're missing a head or something. But you should, yes, have semicolons in these places here. I don't even know if semicolons are part of the original. Semicolons haven't been critically necessary in JavaScript for a very long time. There's a lot of really ugly JavaScript out there that doesn't use them. So we've got this little web server that's running. Lil Nako says you can use NodeMon. Yeah, I've used NodeMon. If you Google libraries for like automatic restarting Node Express servers or automatically restarting Node interpreter, there's lots of things. There's tons of stuff. Like there's this limitless basket of things in this world to interact with. So this is kind of like a web server now. Now what I want to show you is like a really common way that you would kind of package up your React stuff ready to be served, right? So this is like a back end, for lack of a better word. And then we've got our front end, which say, you know, is in our week 2 folder and it's in front end. We saw before that when we work on a React.js thing, we run yarn start, which will give us like a development environment where it's constantly transpiling and loading it in the browser and all the really cool stuff that makes development really easy. And we saw that when we do yarn build, it transpiles it once and it puts it all inside the build folder. And we also saw that if we were inside the build folder and we started a web server in that build folder, that it would start a web server on some port and we could access that like on localhost 8000. And there was our web page. So the question is then, how do we tie these two concepts together elegantly? Let's say you're trying to make a nice little project to work for you. So what we would do then is once you build the React.js app, what you can actually do is you can use like your Express server to serve it statically. And what I mean by that is like you can actually set a folder in Express.js, which when someone accesses, it will simply just give you those files. It's not going to do anything fancy. So we could Google that, Express static folder. Okay, serving static files in Express. Great. I don't keep this on the top of my head. What does it say? It says, give me a better example. Yep, okay, app.use something express.static. So it's basically like if someone accesses this route, I'll just serve them whatever files are in this particular folder. So let's try that out. It wants us to import another library. So what do? We go back to our JavaScript here. I'll import another library called path. And then somewhere in my server here, I'm going to say that if someone let me put word wrapping on. You know, if someone tries to access, and in this case, I'm actually going to do the root URL. So we're going to get rid of our hello world route. If someone accesses the root URL, what I would like to do is I would like to give them all of the files inside of frontend/build, like this. So that like when someone accesses the slash, I just go inside my frontend build folder, which we saw before. It's missing from my directory list, but we saw before that's where all the transpiled code goes to. And we'll see if we can serve that. Let's try that out. So I'm just going to restart my node server. Hope it works. You'll notice here that I didn't have to npm install the path library. Why did I not have to do that? I'm not 100% sure. I'm pretty sure path is one of the Node.js libraries that's like built into the core interpreter. Like is installed with it. Just like in Python now, there's a few libraries you don't have to pip install. But let's load this up now. So if I load up localhost 3000, there's my app. So what's actually happened here is that I have got an Express server that's written in Node.js, and I've got a React.js app over here that's written in kind of Node.js. What's happened is when I build my React app, it transpiles it to like browser-ready compatible JavaScript, which my server is just serving when someone's like trying to contact my server. So this is actually like one of the most common ways that you'll see people build little websites is they'll actually build their front end in like a React app right in the front end folder. And then they'll actually have all of their like API routes on that same Express server. So this is kind of what's giving people the React app. And this is kind of where you add your like post, get, push routes and stuff like that. Peng says, so any backend framework can serve React.js static web content, for example, Sprint Boot. Yeah, so this is the big thing to take away from like today more than anything in my view, at least the end of it is that, again, for the next few weeks, we're going to be writing JavaScript by hand. We're going to be understanding what's actually happening. What's happening, how is it manipulating the DOM, what are browsers interacting with, and then in the latter weeks, we're going to be writing React.js, knowing that all that stuff just transpiles into versions of what we've been working with in the middle of the course, right? So all this React we write today, this just transpiles into browser-compatible JavaScript, and we're just going to be writing browser-compatible JavaScript ourselves for the next few weeks. And that's the cool thing about these frameworks like React and Transpilation is that it's just transpiled to a static folder. It's totally simple. You can just serve it as like raw HTML. In fact, I did this the other day in for our course, COMP6080 at CSE. CGI.CSE. set this up, I built this in for React, where we're building a leaderboard for missing a URL. We're actually building a leaderboard, right, for one of the projects, and this is just built in React because it's so quick. It's so quick to build things in these frameworks, React or any other kind of framework. And it was just written in React and then transpiled and just like dumped here as like a static file. So like this isn't like people are like, oh, how are you like running React on this? It's like we're not running React. Like React is like a development tool, right? And the development tool can just build and transpile to like static files. Like it's like just quite literally static files. There's no server running here or anything, right? It's just really straightforward. Here is the JavaScript, and browser, can you please do with it what you know how to do? So again, yeah, you have your like Node.js environment, and again, I hope this really paints the picture, because if you want to kind of get a sense of the history of these things again, what used to happen was in the past you kind of would have I mean, this is like back in the day for me as well, was you in the past you would have like a front end over here, and that front end would just be like HTML, CSS, JavaScript, all static files, just served on a web server. And then over here you'd actually have a server which might be written in something like PHP, Perl, Java, whatever, and it was actually like a compiled language running on a web server by itself. Or Python became super popular. You had the Djangos and the Flasks, and the big revolution that kind of came about, the lamp stacks. The big revolution that came about was kind of once Node.js allowed you to do command line interpretation, and people realized, hey, I can actually build servers now. Because suddenly I can do with what I used to do with Python, I can do that with JavaScript. That's when you started to get like the Express and other servers over here. And then people were like, oh my God, we're writing that in JavaScript too? That's awesome, because now we can have these projects like the one you just saw where the entire code base is in JavaScript. And then on top of that, once people said, you know what? Screw writing JavaScript. JavaScript is an ugly, awful language, so we're going to develop these frameworks like React.js, Vue.js, AngularJS, which we can use our Node.js here to essentially compile it back to these things that have always worked, or transpile it more specifically, like this. Suddenly now you can build a project with these tools, and a project with these tools, that all run like via Node, like with Node.js. And there you go. That's it. That's like your whole stack. And this is very, very intensely revolutionized how web works. I as I said at the start, like I have been working in this field for a while, like 12, 13 years, and it's changed it a lot, because the power now you have of building these like unified code bases is really strong. You know, and I'll give you a really, really simple example, which is I think really what paints to the core of, because Curtis just touched on it in the chat. You can share a bunch more of your code between the front end and the back end. I'll show you a really cool example of something that I just remember the first time I did it, I was just like, wow, that is crazy cool. In the front end folder, I'm just going to make another file, and this file, I'll make it in the source folder. This is not the way you'd normally do it, but let's make a file, and I'll call it like name. Name.javascript. It's going to be a really simple file. All it's going to do is it's going to export a function. You can not worry about exporting right now, but it's going to export a function called getName, and all that's going to do is just return like Hayden, right? Like the name. Really simple. Now what I'm going to do is in my app.js here, instead of saying hi Curtis, I'm actually going to print my name, like this name. And how am I going to get the name? Well, I'll import that. So import name from the file name.js. So that's the file I just made, right? Should be pretty simple. We can test if that works, because we can go into our front end. We can start up our development environment for React. And when I run it, you can see here it's not working. It says save to high, but I asked to save to name, but name isn't working. So what do? I can console log it. Let's debug it quickly. Let's see what's printed out in the console. It's actually giving me the whole function. So it's like, oh, okay, I'm not calling the function. Because what I'm actually importing is a function, not a variable. So now I have to call the function, right? Why these names don't match up, that's again, we're going to talk about importing in a later week. Today's just trying to convey a concept, not trying to get you to go and do all this stuff. I just keep reiterating that to everyone, right? So we have our name there, but here's the other cool part. I can now go to my server here, and I can actually say, for instance, const name equals require frontend / source / name, and then here I could add on my backend goodbye the name. I can insert this like this. I could say name like that. And now if you think about the process of what we've been doing, I can build my React app, which will transpile it from cool, fun JavaScript to boring old JavaScript. And then when I run my server, which is going to serve that boring old JavaScript, what was I saying? Server. I think I need the / there. Sorry, paths in Node. Oh no, this is all painful stuff. This is all versioning. This is like an actual problem here. So like what's happened here is like quite literally the Node server has been like, I can't interpret this because this is new JavaScript, and there are ways you can get around that. It can be very painful and complicated sometimes, but just bear with me. This is what you might write here instead. I think this is the old school. Oh, it does not like this. See, now React's complaining. Now React's like, what is this? I'm not 100% sure. Maybe if I import it the old way? I mean, this is kind of the challenge of web, right? I was actually talking to import in body of module. Oh, God. Nah, it doesn't like that. Yeah. Okay. Let me just quickly chat through this because it's actually an interesting example of versioning. It's really funny. Oh, thank you. You're right, Curtis. Actually, I understand what I need to do now. This is actually just going to be a function that returns Hayden. This should do it. It's funny because I was actually talking to the head of school about this when we were talking about another course, and he was talking about learning React, and he was like, I'll hopefully just pick it up quickly, and we were just talking about it. He's like, it's like just crazy, and I was like, yeah, this is like the conundrum with modern software, right? Is because it's just abstractions upon abstractions upon abstractions, everything is very confusing. Everything is very complicated. And that's good because it's really quick to build things, though at the same time, the downside is things can be very disorienting. So I've built that now. My front end's returning Hayden, and then when I actually go to run my Node.js server, the address is in use. When I go to run my Node.js server on port 3003, and I then try to access my route, which is /by, I get Hayden here. So what we've actually done is we've written code for a front end and code for a back end that is using the same information. It's actually using the exact same, stuff from the same language. So this is extremely powerful. Okay, that's kind of the crux of things. I just want to recap for everyone again because I'll go back to my paint diagram. So in this course, what we're really learning in this order, which is pretty simple, is we spend the first week doing HTML, CSS as the core topic. We spend the next few weeks, 2, 3, 4, 5, with you getting really comfortable with vanilla JavaScript, like untranspiled JavaScript, right? JavaScript that just runs on the browser normally without any transpilation, without any Node.js, because pretty much anyone who's associated with this course feels that it's important to understand what's actually happening with the transpile code. As you get comfortable with that, because again, remember the first weeks of this course, like until like week 5, everything you're doing is just static files that run on a browser. That's all you're doing. After the mid break, in week 7, 8, and 9, we actually get you starting to work with a React or, one of the frameworks, which in this course is React. We've talked today about how you can transpile from React to this kind of older school vanilla JavaScript with Node.js. And we've talked about what the hell Node.js is again. We've talked about, is it JavaScript? We're like, no, Node.js is a runtime environment built on Google's V8 parser, right? That essentially just like reads JavaScript and does stuff. It just runs JavaScript. And a web browser is a similar tool but different. It is a runtime environment too that has different kind of capabilities, still built on very similar engines, that's just capable of actually running JavaScript too in a different way. And then all this other stuff we talked about with servers is totally tangential and was just kind of for fun. And was just kind of about, these are some things you can do with Node.js. Because otherwise you're kind of just like, what is all this stuff? And it's like, here is like, this is an example of why this has become popular. So the thought I'll just leave you with again, because I've taught a lot of my life. It's like, what happens with these things is you have some people watch it. They probably haven't made it this far if they're worried, but it's like, you get to this point and you say, okay, this is a lot of information to take in tonight. And I'll just say for the 6th time again, pretty much everything we learn tonight has no practical bearing on what you're doing in the next weeks, right? At least until after the mid break. So like, it's like all kind of tangential to that. Most of like what you need to know is in the pre-recorded lectures. What today's about is to understand how things that we're learning, things you've heard about, things you see hints of, all fit together in like that's why this lecture is referred to as the JavaScript ecosystem, because there is this big complex world of different things. And if you understand how it all fits together, then as you go forward in the future weeks and you learn a bit more about React and you learn a little bit more about, you have to deal with NPM in maybe a shoot question, or you're working with vanilla JavaScript and you're Googling a problem and you're seeing React code and you're like, can I just use that React code here? You see how all the pieces fit together. So that's the purpose of today. Hopefully we have fulfilled that. Whether or not we fulfilled that is largely up to you, because you can be a kind soul to me tonight and you can fill out the feedback form where you can take a snapshot with the QR code thing. You get your phone out. Just for me, it takes all of 20 seconds depending on your internet. You just pick the lecture and you just give it a rating. You can leave some optional feedback if you want, and we use that to improve things in future terms. Which is great if you care about future generations. And if you don't, then cool. That's fine too. That's totally understandable. Post a link. I used to have links. It's all the same form. I'll share a link in the chat. I should probably just put a link up somewhere, but I'll put a link in the chat now, but we're pretty much just at the end. So I'll send out a notice this weekend. There really isn't much of interest going on at the moment. You're just working on your first assignment. It's all pretty straightforward. The first assignment should be relatively easy, as I've encouraged everyone to do. So far, try and get your first assignment done. I would encourage you to try and get your first assignment done this weekend so that you can start assignment 2 early. That is my advice to you all, because as I've said in previous terms, what happens is that students say that there's not enough time for assignment 2, and we can't make assignment 2 due later without making assignment 3 even worse. So we're starting to just encourage people to make it due earlier, and I'll just reiterate it to everyone again. If I was being forceful, because I think I know what's better for you, I would make assignment 1 due at the start of next week, at the start of week 3, right? We could make it due on Monday night next week to force everyone to start assignment 2, essentially. But I like to think you're all adults and mature and able to manage your time. So we're going to have an overlap. So there will be some of you here that because of personal reasons, other reasons, you just prefer to spend more time on assignment 1. There'll be people who take my advice and really try and get assignment 1 done so they can start on assignment 2. Totally up to you. That's just my encouragement because I'm interested in your general well-being and satisfaction throughout the course. And Jared says, will we be allowed to use external libraries throughout the assignments? Yes, for assignment, you'll be able to use external JavaScript libraries in assignment 3, and you'll be able to use external CSS libraries in assignment 2 and 3. And assignment 2 will come out on Monday as well. Good timing, Samir. Yeah, it'll come out on Monday. So we've written it. I got to clean it up and sort it out over the weekend. It'll be released on Monday night probably, sometime next week. It's not like hard. I just want to stress this. It's not like the hardest thing in the world. It's just we see students try and start at 10 days out, and they just find they're a little bit too busy. Yeah, like Bootstrap, CSS Bootstrap. That's all totally fine for assignment 2. Okay, well, attendance has dropped pretty regularly since 7:20, so it must be late and everyone's getting tired. Thank you again for all those who've tuned in. I hope this was a good background. This isn't core content. This is meant to fit pieces together. Don't stress. If you found it interesting and some light bulb moments came off, that's the whole point of tonight. It's not so you go and reproduce any of this stuff. That all comes later. Post on the forum if you need anything, and otherwise I'll see you all next Wednesday for the lecture. You'll hear from me on Friday, and anyone who turns up to my tutes, I'll see you on Tuesday. Have a great week, everyone, and thanks for coming again.